Hello. Hello, am I audible? Okay, so let's start today's session. Welcome for the last live interaction session number 12 on MATLAB based programming lab in chemical engineering. So this is my introduction. I guess now whoever is following this already knows. So these all recorded lectures are getting uploaded on this YouTube link, and you can connect me here via my webpage and LinkedIn. So let's start today's session. So in previous session, we started looking at minimization, or more better term, optimization of a function, of a multivariable function using fminsearch option and fmincon. So we will just revise these two examples once again very quickly, and then we are left with some more 2 or 3 problems. So we'll complete them, and after that we will start with our next set of part, that is data fitting. So let's start with this problem number 4. So we were given our function f of x is equal to x1 square plus x2 minus 11 whole square plus x2 square plus x1 minus 7 whole square, and we were supposed to find a minima with tolerance of 10 raised to minus 8 and initial guess with minus 5. So let's solve this problem once again. So what did we do last time? We first wrote down the function. So our function was f of x is equal to at the rate x. The equation was x1 square plus x2 minus 11 whole square. X1, so I will write it down as x of 1 square plus x2 minus 11, x of 2 minus 11 whole square. I will just copy this thing. Then plus x2 square plus x1 minus 7. x2 square plus x of 1 minus 7 whole square. And according to syntax, first we need to give initial guess, and we are told to start with minus 5 minus 5. Okay. Then our solution is like x comma f well is equal to f mean search, then function comma x0. This is the normal way of solving this problem. Correct. So we got some answer of minus 3.78, minus 3.28. But what is additionally told to us, we are supposed to use optimset to give the tolerance of 10 is to minus 8. So we need to add that. So for that, we need to use, I'm just defining it using options. So options is equal to optimset. What do I need to, so I can show something display. So what do I want to display? I can display iteration number. Further, I can display my tolerance, that is 1e minus 8. Correct. And here I need to give options. So it will follow that. And if I run this, there is some error. Options is equal to optimset display iteration tolerance function. I think here this thing should be some non-real. It is 1e. Okay, yeah, here it's not like this. Okay. So if we run this, so see, we get the same output, that is minus 3.78 and minus 3.28 with this value of less than 10 raised to minus 8. So our correct option is 3.78 and minus 3.78 and minus 3.28, that we are actually getting same. Further, what did we started? We started with fmincon function. So I will just spend some amount of time here again, because this is a bit confusing. So let's first search about fmincon. So next problem we are supposed to solve using fmincon. So this is the syntax of fmincon. So my minimization function f of x is such that c of x is less than equal to 0, c into equation is equal to 0, ax is less than equal to b, AQ into X is equal to BQ and lower bound and upper bound is given. So if we look out this problem, consider the following minimization problem. So this is the function. This is F. Correct? This is my function F that I want to minimize. This is my F of X. F of X. Now my first constraint is x1 plus 2x2 is less than equal to 4. So where does this match? This matches here. Ax is less than equal to b. So I need to define a and b. Further, what is given to us? 2x1 plus x2 is equal to 1. So this equality constraint is given. So this thing c into equation of x is equal to 0. That is given to us. And this lower bound 0 to zero point 0.4 and upper bound same 0 and 0.4 is given to us. And we are supposed to solve this using initial guess of 1 comma 1. So let's try to write down this thing. So here, how can we move ahead? I can write down f is equal to at the rate of x, then 100. What is the function? 100 into x2 minus x1 square whole square. So 100 into x2, 100 into x2 minus x1 square, that whole square. And what is there additional? Plus 1 minus x1 whole square, plus 1 minus x of 1, 1 minus x1 whole square, x1 whole square. Okay, and I will just put one bracket here. So this is my equation that I want to minimize. Now, here, I don't have so my here CQ is equal to 0 is given to us. And C of x is less than equal to 0 first thing. So here x1 plus 2x2 is less than equal to 4. This thing is given to us. So here we have C of x is given to us. Then C EQX is equal to 0. So this thing is given to us. 2x1 plus x2 minus 1 is equal to 0. So we have CQ. Then these two terms we don't have. So we will not bother about this, and we have lower bound and upper bound. Okay. So what is the syntax? Syntax is this one. Okay, so let's try to write it down in MATLAB. So we don't have, first of all, A. So A is null matrix. Then B also we don't have. B is also null matrix. Then A EQ term is also not there. So that is also a null matrix. And B EQ term is also not there. So that is also a null matrix. Okay, what is lower bound given to us? So lower bound for x1 is 0 and x2 is also 0. So it is 0, 0. Correct. And what is my upper bound? Upper bound is 0.4, 0.4. So 0.4, 0.4. This is given to us. Okay, what is initial guess told to us? 1, 1. So my x0 is equal to 1, comma 1. So x0 is also given. And what is my answer? X, comma f12 is equal to fmincon. What is the syntax? We can see it from here. First function, then x0, AB, AQ, BQ, LB, and UB. Okay, so function, then x0, then A, B, AEQ, BEQ, lower bound, upper bound, and we need to give some constraints. So I will just write it down as constraints. Constraints, yeah. So we need to define constraints via some function. So function, let's say, what do we need to define there? We need to define these two terms, C and CQ. Okay, so function will give me C, comma CQ. That is equal to, what is the name of my function? Constraints. And constraints of X. And end. Okay, so what is my first equation? C of X is equal to, what should be there in C of X? From here, C of X is less than equal to 0. So what is there here? x1 plus 2x2 minus 4 is 4, x1 plus 2x2 less than equal to 4. So I need to write down as x of 1 plus 2 into x of 2 minus 4. This is my first constraint, and my second constraint is equal to 0 kind of. C equation equal to 0. So what is my equation? 2x1 plus x2 is equal to 1. So 2 into x1, 2 into x of 1 minus, sorry, plus x of 2 minus 1. Okay, so these two constraints are there. So if we run this, we will have our answer. So we are getting 0.4 and 0.2, but what are we asked? Up to one figure, what is the function value? So what is the function value? Function value is 0.52. Correct? So that is our answer. Okay. So this is how we can use fmincon function. This is a bit complex, but it is, if you practice it, it is easy. So this syntax just you need to remember that c of x is less than equal to 0, c into equation equal to 0. And these two are generally, if it is there, we can have a look. Okay. And you need to define them accordingly. Okay. So let's move it with the next problem. This we have already seen in next class, but I'm just revising it because we are going to solve more problems today. So if we move ahead with question number 6, so see here, f of x is equal to x1 minus 1.5 whole square plus x2 minus 4 whole square, subject to the constraint 4.5 x1 plus x2 square minus 18 is equal to 0. So this first constraint is in this form. C of x is less than equal to 0. Then second constraint is minus 2x1 minus 2x1 plus x2 is less than equal to minus 1. So that is in term of this less than equal to b. So a and b are given here. Then 0 is less than equal to x1 and x2 is less than equal to 4. So we are given lower and upper bounds. Correct? So let's try to solve this. So my function is x1 minus 1.5 whole square plus x2 minus 4 whole square. So I will write down here x1 minus 1.5 whole square x of 1 minus 1.5 whole square, and my second x2 minus 4 whole square. So x of 2 minus 4 whole square. Okay, this is my function. Now here I have value of a and b. So a is minus 2, 1. Minus 2x1 plus x2 is less than equal to minus 1. So my a is minus 2, then minus 2 comma 1. And my b is minus 1. Correct? Now here we don't have AQ, BQ term, so we'll leave that. My upper bound is 0, 0 and lower bound is 0, 0. We have to assume that x1 is less than 0 is less than equal to x1 and x2 is less than equal to 4. So we assume that lower bound is 0 and upper bound is 4. So lower bound is 0 and upper bound is 4. And then what is told to us in problem statement? Take the initial guess as the midpoint of the bounds. So what is the midpoint of the bounds? 0 plus 4 by 2, that is 2. 0 plus 4 by 2, that is 2. So instead of doing that, we can just write lower bound plus upper bound divided by 2. But here I need to use dot because we are doing it with matrix. Okay. So this we have done, then this syntax is not going to change. Then equation. So my equation is 4.5 x1 4.5 into x1 plus x2 square plus x of 2 square minus 18 is less than equal to 0. and I don't have this CEQ term, so that will be just a null matrix. We don't have that constraint. So if I run this, we will have the answer. So I'm getting answer of x1 is 1, x1 is 2, and x2 is 3. And my function value is 1.25. Now, what is asked to us? Take the initial guess as the midpoint of the bounds and give your answer up to one figure after decimal. So we can assume that they have asked us about F12 and that is coming out to be 1.25 in our case. So this is what we looked in the last week's problem. Okay. If these things is clear, then we can move ahead with the next problem. So let's try to understand this problem. Suppose, okay, let me convert it here. Okay. Suppose a right circular cone is to be designed with a minimum possible surface area. So the surface area should be minimum. The cone should have a minimum volume of 1500 meter cube. Maximum base radius is 10 and maximum height is 20. Take the initial guess of R and H as 5, 5 and use fmincon and find a minimum value in meter square of the lateral surface. Okay, so we will have to formulate this problem. So my volume is given as, okay, so what will be the volume? Volume will be equal to 1 by 3. Sorry, 1 by 3. Wait a minute, let me write down somewhere else. Let's do one thing. Okay, so my volume V is equal to 1 by 3 pi r square h, and that is minimum volume of 1500. So it should be greater than equal to 1500. Correct. So this is my first constraint. Then what is told to us, base radius is 10 meter maximum, sorry. So r is less than equal to 10 and height is less than equal to 20. So we have upper bound. So what should be the lower bound? Lower bound cannot be a negative value. So this number should be always 0. And what are we supposed to do? We are supposed to find a minimum surface area. So what will be the surface area? Surface area will be this pi r square plus pi r l. Okay, so I will keep pi into r common, then r plus l. And what will be the value of l according to Pythagoras theorem? L will be square root of h square plus r square. So it is square root of h square plus r square. Okay, so this is my minimization function that I want to minimize using these 3, 1, 2, and 3 constraints. Okay, so let's try to solve this problem. So what is the function? Okay, let me create one new file. Okay. So okay, let me add one comment that r is equal to x of 1 and h is equal to x of 2. Okay, so my function f is equal to, what is the value of that? Pi into r. So I can write down pi into r. R is my x of 1. Pi into r into in bracket r. So r is x of 1 plus is there anything you want to ask? Because here there is showing 1. Let me just check it. Okay, it's nothing. Okay, I don't know why it's showing 1. Okay, so pi into r square root of pi into r plus square root of h square plus r square. The square root sqrt of x of 1 square plus x of 2 square. Yeah, so this is the function that I want to minimize. So I will have to write down it as this. So it is at the rate x. X. Correct? Now we are given initial gas as 5, 5. So let's keep x0. I'm sorry. X0 is equal to 5, 5. Okay. This is my initial gas. Now I need to define all these terms. So we know that these all A, B, AQ, BQ are 0. So A is a null matrix, B is a null matrix, AEQ is a null matrix, BEQ is a null matrix. Then we have lower bound. What is lower bound? In both cases, it is 0, 0. And my upper bound is equal to, what is my upper bound? Upper bound is 10, 20. You need to follow the variables, right? Okay. So yeah, this is how we can do it. Okay, I just want to follow the, so I will write down this as here. Okay, we have made one small mistake. Here we need to mention that this is the function of x. So it is at the rate of x. Okay. So this is that. Now what do we need to do? We need to define x comma f well is equal to fmincon. We are supposed to use fmincon, right? We are supposed to use fmincon. Yes. So fmincon. Then first we will write equation f, then initial gas x0, then A, then B, then AQ. This is the syntax that you should follow. It's fine if it's a null matrix, but we are supposed to write that. Then lower bound, then upper bound, and we need to create a function for constraints. Okay. So my constraint function is function. What do we have in constraint? C and C equation that is equal to constraints of x and n. So let's see, we have C or C equation. So my this term is there, pi r square h by 3 minus 1500. Okay, that is my first constraint. And my second constraint C eq. There is nothing, no other constraint than that. So this term that equal to 0, we don't have anything like that. So we have C eq. C eq is a null matrix. And I have C is equal to, what is that value? 1500 minus pi into r square. So x of 1 whole square into h, x of 2 divided by t. Okay, so following these constraints. Okay, this spelling is wrong. Constraint. Okay. I hope it is, yeah, this is correct. So see here, this color has changed. So if I run this thing, okay, so we are not supposed to run it. So what do we do? So let's do one thing. It is not supposed to find, or it is supposed to find, wait. Um, yeah, it is supposed to find FL is equal to 802.3806. So what is asked to us? Surface value. So that is coming out to be 802.3806 meters square. Okay. So this is how we can solve this. Let me save this problem. So this is our problem number 7. Okay. So this is how we can solve a minimization, maximization, optimization, basically optimization problem. Okay. So let's move ahead with the next problem. Problem number 8. A heat exchanger with hemispherical heads of volume 70 meter cube has to be built. Two heads cost 640 rupees per meter square. The cylindrical wall cost 320 per meter square. Find the radius of the tank that will minimize the total cost. Okay. So here, what is my equation? Okay, we have two hemispherical heads, right? So my volume will be equal to, it is hemispherical. So it will be equal to 2 by 3 pi r cube plus 2 by 3 pi r cube plus cylindrical. So that is pi r square h. Okay. Okay. So my volume is equal to 4 by 3 pi r cube plus pi r square h. And what is the value of volume given to us? That volume is equal to 70, right? Okay. So this is one thing. Okay. My next equation is cost equation. So my cost C1 is equal to 640 per meter square. So two hands. So area is 2 pi r square into 640 plus 2 pi r square into 640 plus 320 into 2 pi rh. Area of cylinder 320 into 2 pi rh. So my answer is, this thing is 640 into 2. This term is appearing two times. So my answer is 2560 pi r square plus 640 pi r h. So can we replace one thing from here? So we can replace h as equal to 70 minus 4 by 3 pi r cube divided by pi r square, and I can put this value of h as here. Okay. So let's first try to write down our function. So this we are supposed to solve using fminsearch. Okay. So I will write down this function first, clear all, then CLC. Then my function f is equal to this one, minimization of cost. So that is 2560 pi r square. So I will write at the rate of x 2560. It is 2560, right? 2560 into pi into r square. So that is x of 1 square plus this term 640 into pi r into h. So we can see that, okay, let's write down like that only. Let's not modify anything. So that is 640 into pi into r Actually, we don't need to do x of 1 and x of 2 because we just have one variable. So I can just write it as x into this term 70 minus 4 into pi into x cube divided by 3. This whole term divided by pi into x square. Okay, so this is the function that I want to minimize. Okay, so what is the initial guess given to us? Okay, take the initial guess for the decision variable as 1. So let's say x0 is equal to 1. So my function, it is really a simple function. So it is x comma fwell is equal to fminsearch f comma x0. Okay, so if I run it, I'm getting the value of x as minus 6.328. That doesn't make any sense actually. So we have made some mistake. Plus 640 pi r. Yeah, here is the mistake. So this bracket for this pi into r square. Now this is correct. Okay, we have made some mistake. I guess this mistake is in function only. To r into this is ending here. Yeah, this is whole divided by, yeah, this is the mistake. This term pi r square is divided by whole this term, not to just this. Okay, that is the issue. So this bracket is ending here. This bracket is ending here. Wait, this bracket is ending here. And this equation bracket is ending here. And that is divided by pi r square. Okay. We are getting the same answer. We are doing some mistake. Pi into x square plus 640 into pi into x. Let's do one thing. Let's add one more bracket here. Mm, yeah, now it is coming out. What was happening? It was if there was no bracket here, right? It was just doing divide by pi into x square. It was not doing whole divide by pi x square. That was the so. Okay, so what are we getting? We are getting our value of radius as 1.615. We are supposed to give the value of radius only. So that is 1.615 and volume is 4.1724 into 10 raised to 4. So that is 1, 2, 3, 4. So that is 41724. Value of cost 41724. Okay, so this is how we can solve. This was really a very simple problem. So let me save this. So this one is, I guess, problem 8. Okay, so this is also done. So this is what we have looked about function optimization. Okay, so now let's very quickly go ahead through some theoretical questions and then we'll move ahead with the data fitting part. So the question is use of gasoline blend like gasoline mixed with tetraethyl lead in internal combustion engine. What does it do? It increases the octane rating of the fuel. It allows engine to operate at high compression ratio. It avoids auto ignition of fuel and all of the above. So the correct answer for this thing is all of the above. When we add tetraethyl lead, so that also increases the octane rating. That also allows engine to operate at high compression ratio. That avoids auto ignition of fuel, and that matches with our answer all of the above. Okay, so the correct answer is D. Okay, the next question is which of the following was used as anti-knock compound in gasoline? So what is knocking? So when the spark is advanced, burning gas is compressed by the rising piston, and therefore temperature and pressure are both increased, and thus tendency to knock increases. This is correct? Right. In spark ignition or in SI engine, what happens? The possibility of knocking can be reduced by decreasing the compression ratio, as a reduction in compression ratio will result in generation of lower peak temperatures. And in SI engine, knocking occurs before TDC and because of early combustion of charge air or more than one flame propagation. So what are the factors that affect our knocking? So one is the compression ratio. And what happens if the compression ratio is higher? It will result in higher temperature of the charge, and because of that temperature, this knocking will increase. The one another factor is inlet air temperature. So what is the effect of inlet air temperature? So it is the same effect as the compression ratio. So higher the inlet temperatures, then higher the possibility of increasing the knocking. Then one more factor is advancing the spark. So advancing the spark will result in more compression during the sparking. The increase in temperature during this sparking will be higher, and hence tendency to knock will increase. And so by retarding the spark, the tendency to knock will also decrease. Then one more thing is coolant water temperature. So by increasing coolant water temperature, what will happen if you are increasing coolant water temperature? Less heat will be carried from the engine, which will increase the engine temperature. So knock will increase. One more factor is engine speed. So that is to avoid the knocking in SI engine, and the engine speed should be higher. For that purpose, our engine speed should be higher. Then octane rating, that should be always as high as possible. So when we add tetraethyl lead, so the correct answer is this only, the one that was here only, tetraethyl lead. So what will happen? Tetraethyl lead is an organolead compound. What is organolead? So organolead, what is the structure? CH3CH2 4 into Pb. So this is organic part and this is lead. So this is called organolead compound. So this organolead compound, it was mixed with gasoline before in beginning in 1920s as the patented octane rating booster that allows engine compressions to be raised substantially, which in turn increased the vehicle performance or fuel economy. So by adding tetraethyl lead to isooctane, knocking can be completely suppressed. So our answer is this tetraethyl lead. These are theory questions. These may be there in your final exams. The next question is gasohol content. So what is gasohol? So gasohol is nothing but the mixture of ethanol and gasoline in the ratio of ethanol 10%. I'm sorry, ethanol 10% and gasoline 90%. Then next question is stoichiometric air fuel ratio of alcohol when compared to gasoline. So that is lower. Stoichiometric air to fuel ratio of alcohol, that is always lower compared to gasoline. Choose the correct statement. The first statement is octane number of isooctane is 0. This is completely wrong. What is octane number of isooctane? That is 100. The next statement, so this first is wrong. The next statement is octane number of paraffins increases with increasing number of carbon atoms. So this is also wrong. That basically decreases. The next option is branched chain paraffins have higher octane number than straight chain paraffins with the same number of carbon. This is absolutely correct. And the next part is the aromatics have lower octane number than naphthalines with the same number of carbon atoms. This is not lower, this is higher. Okay. So our correct answer is option C, that branched chain paraffins have a higher octane number than straight chain paraffins with the same number of carbon. So if we see ethanol, sorry, if we see octanol and if we see isooctanol, so that for isooctane, or let's say if octane and isooctane, so for isooctane it is higher compared to octane. Okay, next question. Which of the following is desirable in gasoline but undesirable in kerosene? So the correct answer is B, aromatics. Aromatics are desirable in diesel and kerosene but undesirable in gasoline because of its low viscosity index. Next question is which of the analysis is not done by MATLAB explicitly? So numerical computing that we are anyway doing from day one. This we can do. Algebraic solutions that also we are doing, plant planning analysis that we can do, and dynamic system simulations that also we did. So correct answer is option C, that we can't do. Okay, so this is all about optimization part. So in optimization part, what did we learn? We learned about fminsearch option, then we learned optimset where we can give tolerance of the function. Then further we also learned about fmincon function, where the syntax is something that you need to remember if you are going to sit down for your examination. And further we looked at some what do we say? We looked at some problem statements where one problem was to minimize the surface area of a cone, and one another problem was to optimize the heat exchanger cost minimize the heat exchanger cost by keeping the volume of the heat exchanger fixed. Okay, so this is all what we learned about optimization problem. So now further, what are we going to look at? We are going to further have a look at this, what do we say? Data fitting problems. So let's start with data fitting problems. So my first problem is, this is from theory questions that you have learned in your class. The first question is law of mass action stipulates that the rate of chemical reaction is conforming to the rate reaction stoichiometry. So this sentence is completely true. How? So this is from your theory. I will show you some. How can I insert a slide here? So what is that? So enzymes generally do not follow this law of mass action. So that is V is equal to. So that is nothing but V is equal to. Sorry. V is equal to. V is equal to K into substrate concentration. Okay. So these enzymes do not follow the law of mass action. How do they follow this? So let's say this is my reaction substrate. It is combining with enzyme. So this is reversible. So let's say this rate is K1, this rate is K minus 1. So it is forming some substrate extract enzyme. So then it is enzyme is separating out and substrate it converting into product. So if I write down the rate equation, how can I write that? So I can write ds by dt is equal to C. S is forming from this one. So it is minus K minus 1 SE because S is forming and here S is consuming. So minus K1 S comma E. Correct? Then my rate of enzyme dE by dt is equal to minus K1 S into E, correct? Plus K minus 1 SE. Here also it is formed. So plus K2 SE, correct? Okay, then my next term is DSE, formation of intermediate by dt, that is equal to minus K1 S into E plus K minus 1. Sorry, it should be plus K1 because this is converting. So this is forming, so it is plus. Here it is minus SE. Here also it is converting, so minus K2 SE. Correct? This is how we can write down this equation. And if I want to write down full product formation, so that is dP by dt, that is equal to only one term, K2 into S. So this is how we can write down our rate equation. So okay, so for this problem, our correct statement is this option A. So let's move on with the next problem. The line where work plot was widely used to determine important terms such as Km and Vmax in enzyme kinetics before the availability of nonlinear regression softwares. What is the x-intercept of this plot? Okay, so okay, so what is the equation? So my equation is V is equal to, so this is the equation, 1 by V is equal to Km divided by Vmax into, I'm sorry, into 1 by S plus 1 divided by Vmax. So this is my equation, and if I compare it with Y is equal to M into X plus C. So if I plot 1 by V versus 1 by S, then my slope will be equal to Km by Vmax, and my Y intercept is equal to 1 by Vmax. Okay, but we are supposed to know the x-intercept. So how we can write down x-intercept? So x-intercept is given by minus of C by M. So minus of C, that is minus of 1 by Vmax, divided by slope, that is Km by Vmax. Correct? So my correct answer is minus of 1 by Km. This is my x-intercept. So be careful. You are asked about x-intercept, not y-intercept. Okay. So the correct answer is this one, answer D, minus 1 by Km. Okay. So let's move ahead. Okay. So let's first complete the theory questions. Okay, let's move ahead one by one. So my question 3 is, the vapor pressure of water at different temperatures are given in the following table. So here temperature versus vapor pressure is given. If a second degree polynomial is fit to the data, then sum of the coefficients of the polynomial is what? Okay, so how am I plotting it? P is equal to, it is told second degree polynomial. So my second degree polynomial will be P is equal to A0 plus A1 into T plus A2 into T square. This is the second order. So we have P and we have T. And we need to find the sum of these coefficients. So we need to tell what is A0 plus A1 plus A2. This is what we are supposed to say. Okay. So for that, Let's move ahead to the MATLAB help section and let's search about polyfit. Hmm, okay, so P is equal to, what is the syntax? P is equal to polyfit of x comma y comma n. So degree n. So let's say if my degree is 2, so my equation is P1 x1 x square plus P2 x plus P3. Okay, so here they are writing equation like this. Okay, so here their equation is in this term. Yeah, it is actually same. A2t square plus A1t plus A0. Okay. So if they have given some example, let's first try to solve this. See, create a vector of 5 equally spaced points in interval 0 to 1 and evaluate 1 plus x inverse. So let's do this exercise problem before moving ahead with our actual problem. So what is that thing? 5 equally spaced point between 0 and 1. So I can write x is equal to lean space 0, comma 1 and how many points? 5 points. Then what am I supposed to evaluate? Evaluate y. Y is 1 divided by 1 plus x. So my y is equal to 1 divided by 1 plus x. But what is the issue? Here my x is a matrix. Okay, so I need to put one dot. Then what can I do? I can fit one polynomial. So let's say I am fitting this order of polynomial p. So see, this is my polynomial. And if I run this, I will get these coefficients. So if I remove this, okay, so these are the 4 polynomial A0, A1, A2, A3, A4, A5. Okay, so this is how we can fit. Okay, so this was just one exercise. Further, what is given in help section? Let's try to see it. Error function they are fitting. So see, this fit is like this, but actual term is like this. So not able to fit everything. So see here versus population. And they are fitting some kind of polynomial. So see, that should always increase and that is increasing. Okay, line regression we will see later. Okay, so let's try to solve this problem. So I will just first write down clear all CLC. Okay, so my temperature is given as 300, 305, interval of 5. So I'll write down as T is equal to 300, then 305, 310 like that. So 300 to 300 and what is the last point? That is 330. And what is the interval of 5? Okay, this is my temperature. And what is my P underscore vapor? So that is given to us as 3.54, 4, then 4.72, then wait, 4.72, then 6.23, 6.23, then 8.14, 8.14, then 10.54, then 13.53, and 17.21. So this is my data. So I want to fit it. So let's say my coefficient P, let's say coefficient is equal to P underscore vapor. What was the syntax? X comma Y comma N. So what is on my x-axis? My x-axis is of temperature. Y-axis is of my vapor pressure. And my degree is second order I want to fit. And I want to know the sum. So sum is equal to sum of coefficient. Okay, so this is what we are supposed to see. Let's just say this answer first. Yeah, okay, here it should not be P underscore V, it should be polyfit. Right? So I'm getting some summation as 847. Okay, right now I'm not interested in this summation part, but let's try to plot x comma y, and I want them to plot as dots. Okay, let's plot it and see what we are getting. Okay, sorry, x is my temperature and y is my P underscore vapor. Okay, so this is what we are getting. Okay, this is what I am getting as my curve. Okay, now I want to see how my fitting is. So I will put one hold on. This plot T comma P underscore predicted, or let's say P underscore model comma, I want it as a line. Okay, I want it like that. So I need to first calculate it. So P underscore model is equal to coefficient 0 plus coefficient 1 into T plus coefficient efficient 2 into T square. Okay, so this is what I want to plot. It will throw an error. Yeah, here, here, and here. Okay. Oh yeah, sorry. It should be 1, 2, and 3, not 0, 1. I'm sorry. 1, 2, and 3. And see, let's see what we are getting. See, the model is completely off. It's not at all matching. Yeah, okay. We have made one mistake. Okay, so this is how it takes model. Okay. It is our mistake. Okay, now let's try to plot this. So see, it is well matching. Okay, so here you need to remember that first coefficient is with highest degree. If you see it from here, so it is P1 is order 2's coefficient. So here T square's coefficient is first one. So what I wrote was completely off. Now, let's say I am fitting one third order polynomial. So I will have one more coefficient, right? So let's see how third order is doing. 3. And let's try to plot it. Okay, so let's try to plot this. Third order is also doing well. Okay, so this is how you can fit your data. Okay. Okay, so I'll just save this file. This is A12. A12. This is my problem number 3. So it is problem 3. Okay. Now my next question. So you can use polyfit model to directly fit your data. Okay, now let's move it. A calibration plot is to be prepared for the concentration analysis of nitrobenzene in a UV visible spectrophotometer. The concentration versus absorbance data at 260 nanometer wavelength are given in the following table. Use the polyfit to fit the equation as absorbance equal to A into C plus D and determine the value of A correct to the 4 figures after decimal. Okay, so here my order of n is equal to 1. Correct. So it is really simple. So what do we need to do? Here also, let's write down. Okay, so here also we are having this thing C is equal to, okay, so it is 0 to 0, 5, 10, 15, 20, 25, 30, 35. So 0 to 35 in step of 5. Okay, so this is my C. Okay, now I need to write down the value of absorbance. Absorbance is equal to 0, then 0 0.3, 0 0.3, then 0 0.6, 0 0.6, the next value is 1.0, 1.0, then further it is 1.3, 1.3, and further it is 1.6, 1.6, then it is 1.9 and 2.3, 1.9 and 2.3. Okay, so how can I fit that data? So I can write down coefficient is equal to polyfit of what is on my x-axis? My x-axis is C, that is absorbance, correct? My y-axis, my x-axis is C, that is concentration. Then what is my y-axis? Y-axis is my absorbance. So absorbance and what order I want to fit. So I want to fit the order 1. Correct? So let's try to run this and see what is the answer we are getting. So answer is 0.0652 value of A. Okay, so let's try to plot this here again. So plot x-axis it is C, y-axis it is absorbance. Let's say I want to plot them as just data points. So see, it is coming out to be this. Now let's say I want to check how accurate my model is. So I will use hold on function. I will use plot C, comma, absorbance underscore model, and I will put them as a line. Okay. So how can I calculate that? So absorbance underscore model is equal to coefficient 1 into C plus coefficient 2. And if I run this, so see, this is the plot that I am getting. So all the points are falling more or less into here only. Okay, so let me save this. Okay, I want to check one more thing from the last problem. So this one is problem 4. So wait, let me do one thing. Let me just change the folder so all times we don't have to navigate from here to there. Select folder. Okay, so I want to open one more this problem statement 3. I just want to change that appearance. So my appearance here, I want to just keep this line so I can see how it is well fitting. It is actually well fitting, but I just want to see. So see, this red cow is fitted cow and my O is. So further what we can do, we can give X label. What is my X label here? Temperature. And what is my Y label? Is P underscore vapor. Is unit given to us? If unit is given to us, we must mention the units. See Kelvin and mmHg. So let's write temperature in Kelvin and vapor pressure in mmHg. Okay. Then what further I can give legend as actual data, then fitted cow model. Let's write model. So this is a better way of representing. See, this is how it looks better. So the same thing we must do here also. So let's write down X label. What is X? My concentration in the units of gram per meter cube. So it is okay. There is something we can do it with this labeling part. This thing, but I currently don't remember how we can do it. So I'm just writing it like this only. And this one is my absorbance. And that is in unit of centimeter Inverse, I guess that is in centimeter. Okay, it's not given anything, so let's leave it. Okay, so my here also legend we must add to differentiate actual data and model. So if I plot it, so see here it is from here also it is visible that the data was falling into straight line. But let's say I'm trying to do it one second order fitting. Yeah, let's say I'm trying to do a second order fitting. So what will happen? I will just write down here 2 and it won't work because here from data only it is clearly visible that in C square. So if I run this, it won't fit well. See, C1 is coming out to be 0. So this term is anyway coming out to be 0. So it is only fitting my. So this itself suggests that linear fitting is better. Okay. Okay. So this is what we did with polyfit. Okay. So let me just save this and save this too. So let's say if I were to fit this in order 1, then we can from data it is clearly visible that it is not linear. Correct. So let's try to do this with first order fitting. So it will not be a good fitting that we will observe. So see, all points are not falling on the line. Those are near to line, but that is not a straight line. So it is well or better fitted with second order polynomial. So in this problem statements, you are already told that of which order you are willing to fit. But if it is not told to you, you have to see your data and you have to make some judgment. Okay. Okay, so let's move ahead with the next problem that is quite different. In a set of convective heat transfer experiments for turbulent flow through a pipe, data are generated for Reynolds number, Prandtl number, and Nusselt numbers as shown in the following table. So Reynolds number is given, Prandtl number is given, and Nusselt number is given. It is desired to fit the data by a function of the form Nusselt number is equal to A into Reynolds number is to B, Prandtl number is to C. Okay, and we are supposed to find the value of this B from this thing. So here we can't use polyfit function. So here we will have to use something called L. Sorry, where did that go? Oh yeah, LSQ curve LSQ curve we will have to use. So that is for non-linear curve fitting. So what do we need to do? We need to give function x0, then x data and y data. X0 means some initial guess. Let's try to solve this. So I'm given Nusselt number. Okay, let's first add all the data. Nusselt number 68.3, 68.3, then 146.7, 146.7, then 209.1, 209.1, 289.7, 289.7, then 403.1, 403.1, 434.5, 4.5, and 511.1. This is my Nusselt number data. Then my Prandtl number is 3.5, 3.5, then 18.9, 18.9, then 35.4, 35.4, then 56.7, 56.7, then 89.1, 89.1, then it is 95.2, 2, 112.3, 112.3. This is my Prandtl number. Now my Reynolds number is equal to, okay, 11,500, 11,500, and 13,000, 13,000, then 15,000, 15,000, then 17,800, 17,800, then 21,300, 21,300, then 22,700, 22,700, and 25,600, 25,600. Okay, this is my data. Okay, so I want to write my model is equal to, model is equal to at the rate of coefficient, comma, what do I want to fit? So my equation is this. So I want to write it down as this Reynolds number, comma, Prandtl number. Okay, so first is coefficient of 1 into Reynolds number raised to b. So Reynolds number raised to coefficient of 2 into Prandtl number raised to coefficient of 3. Okay, so one very important thing we need to note here is we need to put dot. Okay. So this is how we can write it. I need to give some initial guess. So coefficient 0 is equal to what is told to us. Is there something told to us? Okay, it is nothing told. So let's take all as 0, 0, 0. Initial guess. And my P is equal to lsqcurvefit. Then my model, that is my function, that my initial guess, that is coefficient 0. Then x-axis, Reynolds number, comma, Prandtl number, and on my y-axis is Nusselt. Okay, so let's try to fit this and see if we are getting it or not. Okay, so here it should be only two arguments. So what we can do, we can write it down as x data. So instead of Reynolds number, I have to write x data of all first row, all columns. Okay, sorry, first row, all columns. Similarly, not here Prandtl number, x data of second row, all columns. I need to define it like that. So this first row is related to Reynolds number and second row is related to Prandtl number. Here everywhere I need to put down the dot. Here also we need to put, yeah, now this should work. So see, I'm getting my coefficients as 0.0198, 0.8185 and 0.3926. Okay, so what am I asked? I am asked to tell the value of B. So what is the value of B? 0.8185. Okay. Okay, so these are my coefficients. So let's try to plot this. Plot. How should I plot it? Let's plot Prandtl number, Nusselt number with these dots. I ideally should not plot it like this. I should plot it with serial numbers, but let's just plot it with Prandtl number. It's not going to affect anything actually. And if I keep hold on, so I can plot Prandtl number, comma, Nusselt number underscore predicted, and we can put one line. Okay, so we can predict that. So Nusselt number underscore model. Let's write model. We are writing everywhere model. Of one. Okay, the same thing. But here we just need to write Reynolds number into Prandtl number. We don't need to. Here it is Reynolds number. And here it is Prandtl. Okay. And if I plot this, so see it is well predicting. It is exactly well predicting. Okay. So this is how we can do this thing. Okay. So we can further improve it. X label as Prandtl number. Y label as Reynolds, Nusselt number. and legend. First one is, okay, what did we write in next last time? Let's write something similar. What did we write here? It is actual data and model. Okay. Actual data. Okay, let me just copy this here. Okay, let's find model. Okay. Okay, so this is how we can plot it. So I will just save this. This is problem number 5. Okay, I hope this is clear to everyone. So we will move ahead with the next problem statement. The surface tension of benzene varies with temperature as shown in the following table. Temperature is given and surface tension is given. If a least square straight line is fit through this data using polyfit function, what is the y-intercept? So we are supposed to basically use polyfit function and in straight lines. So what does this straight line means? That order is 1. Degree is 1, sorry. So I will close this because it's not required. Okay, so let's try to solve this problem. Clear all CLC. Okay. So we have temperature T is equal to 293, 313. Actually, it's an increment of 20, but it's fine. Let's write it down like this. It's not going to matter. 353. This is my temperature and my surface tension. So I will write down. I will write down surface tension. Okay, I can't write it like this. So surface underscore tension is equal to, what is the value of surface tension? Or let's just write it down in short term. ST surface tension is equal to, okay, what are the values? 28.9, then 26.3, then 23.7 and 21.2. Okay, we are supposed to fit first order polynomial. So I will write it down as model is equal to, how can we do it? Let's see from here. Coefficient is equal to polyfit. Okay, let me copy this thing. So first we are finding coefficient with x-axis temperature, y-axis surface tension with order 1. And we will be fitting it. It is order 1 model, right? So we will have only these things. So let's first try to find out coefficient. Okay, we have some coefficients. Okay, let's first try to plot the data. Plot T, comma, ST, comma. I just want to see points. Let's first see how, so see it looks more or less a straight line. Okay, so I will just put one hold on command. I will use plot temperature, comma, ST underscore model with a line on. Let's see if it's fitting well or not. So it is exactly fitting. Okay. So what is asked? What is the value of intercept? So intercept is 66. 66.53. So that is nothing but 67. Okay. So we can also X label is temperature in Kelvin and Y label is surface tension in what is the unit? Millinewton per meter. So millinewton per meter. Okay. And I can give legend. Okay, legend. I will just copy it from here. So see, this is how we can solve it. Okay, so I'll just save this. This is problem 6. So let's move ahead. Blank makes use of fitted curve beyond the range of the observed data. So let's say I'm having this curve, some x versus y. I have some these data points and I have developed this curve. But let's say I want to find the value of y at this x. So what is this called? If I want to find it here, so that is called interpolation. If I am fitting this curve, it is called regression. I am not optimizing anything, but if I am finding it out of my range, then it is called extrapolation. Okay, so the correct answer is extrapolation. Next, which of the following is true about Michaelis-Menten kinetics? So what is that kinetics given by V is so how is it given? V is equal to V max into plus S. Okay. So what is Km? Km is the Michaelis constant is defined as the concentration of substrate at which enzyme is working as maximum velocity. No. So Km is defined as the concentration of substrate at which enzyme is working at not maximum velocity but working at half of the maximum velocity. Correct? So this statement is wrong. So it describes a single substrate enzyme. So this is correct. Option C is Km, the Michaelis-Menten constant is defined as the dissociation constant of enzyme substrate constant. That is not dissociation, but that is association. So this is wrong. It assumes covalent binding occurs between enzyme and substrate. This is completely wrong. It does not assume covalent. It assumes non-covalent. Okay. So my correct answer is answer B. Okay. When the velocity of enzyme activity is plotted against substrate concentrations, which of the following is obtained? So see, when we plot this data, what do we obtain? We obtain the curve something like this. So what is this curve? This is called saturating curve. So what does this curve mean? So when substrate concentration is really low, so what happens? Many active enzyme sites are available. So as this substrate concentration increases, what happens? Maximum possible enzyme sites are available. And what happens? Let's say we are reaching some maximum value of S, and after that also we are increasing the value of S, but there are no enzyme that active sites available for enzymes. So that value is not going to change. So this correct answer is D. This substrate concentration versus enzyme activity, and this type of curve is called saturating curve. Okay. Next question. The molecule which binds on an enzyme to lower its catalytic rate. So it is not helping actually. It is reducing the thing. So it is lowering the catalyst, that is called inhibitor. So it inhibits whatever is happening. So it inhibits the rate. Which of the following is the general mechanism of an enzyme? So it acts by reducing the activation energy. It acts by increasing. So see in catalyst part, what is the role of catalyst? It reduces the activation energy. So similarly, in enzyme part also it reduces the activation energy. Okay, the catalyst efficiency of two distinct enzyme can be compared with the value of Km. The value of Km here we checked. The Km, it gives the association constant of substrate enzyme complex. So how its affinity. So that is told by value of Km. Which of the following statements is true for enzymatically catalyzed reaction? So what does enzyme do? It decreases the catalyst activation energy. It decreases the activation. That is correct. Provides alternative mechanism for reaction to take place. That is also correct. So our answer is C, both A and B. Now this one, for an enzyme that displays Michaelis-Menten kinetics, the value of reaction velocity observed at S is equal to 2 km. My equation is V is equal to V max into S divided by km plus S. So what is S? S is equal to 2 km. So I will put S is equal to 2 km divided by km plus 2 km. My value of V is equal to 3 km Vmax, sorry, not 3 km, 2 km Vmax divided by 3 km. So my value of V as a fraction of Vmax, that is nothing but 2 by 3, that is nothing but 0.667. My correct answer is answer C, 0.66. Next question, which of the following statements regarding enzymes are false? Enzymes are proteins that functions as catalysts. Those are not proteins. Then second, enzymes provide activation energy for reaction. This is correct. Enzymes activity can be regulated. No, we can't regulate, and often specific. No. So this is the correct answer. No, this is the wrong answer. These are correct that enzymes are protein that functions as catalyst. Enzymes activity can be regulated and enzyme activities are often very specific. So specific enzymes have specific activities. Okay, so this is the wrong answer. Okay. So it actually reduces the activation energy. Okay. So, okay, I have some more problems. Let's try to solve this. So we are supposed to fit this temperature versus pressure data in this Antony type equation, ln p set equal to a minus b by t plus c, and we need to find the constants of a, b, and c. So let's try to do that. So similar problem we can solve using lsqfit. Let's clear all and CLC. So let's first write down the temperature. So we want temperature in Kelvin, okay? So 141, 141.1, then 152.6, and okay. Let's write down in order 140.2, then 141.1, then 145.1, then 152.6, then 164. Okay, guys, let's do one thing. I'm sorry. Let's write down in the way order that is given, else it will be confusing for us. So 141.1, 152.6, and 164.4, then 168.3, then 173.5, then 181.0, then 140.2, then next point is 145.1, 171.4, 176.6, and 181.1. I guess if I will just add this 273.15, it will work. Let me just check it. Um, yeah, everything is converted it into Kelvin. Okay, this is my temperature. Okay, what is the value of pressure? So pressure is in mmHg, 214, 317, then 458, then 515, 601, 515, then 601, then 740, then 207, 246, 207, 246, then 564 and 653, 564, 653, and 739. Okay, so this data is taken from some reference paper, and let's try to fit it and match it with this chemical engineering thermodynamics book, James Smith. I guess here LNPZ data is given, ABC constants are given. So let's try to see in which unit it is given so we can also fit it in that unit. So it is something somewhere from here only. Yeah. So temperature is in Celsius and pressure is in kilopascal. Okay, so let's keep temperature in Celsius only. So and pressure is in kilopascal, right? So what is the conversion of mmHg to kilopascal? Um, mmHg to kilopascal, that is 0.13322. So let's do this. Okay, I just want to check the data. Yeah, everything is converted. So now what can I use? I can use this linear square fit. This thing. So I will just copy this code. I don't want to write it down. This thing. So model is coefficient comma x data. So coefficient of 1, that is A, minus B, 2 divided by T plus coefficient of 3. Okay, but here let's, instead of writing T, let's write X data of first row all columns just to keep it consistent. So here I will have to put one dot. Okay. So we have created our model. Then what do we need? We need three coefficients. Okay. So we need three coefficients. So let's assume it 0, 0, 0 only. We will need this lsqcurvefit model coefficient 0. What is on my x-axis? My x-axis is temperature. Sorry, that term is temperature. Yeah. And on my y-axis, it is not pressure, but it is logarithm of pressure. Okay, so we will have coefficients. So let's first try to find out this coefficient and how will it look like. So let me write down, let me just copy just this equation. So here I will just add t instead of this. So my on x-axis. So what do I plot? I plot generally ln p set versus 1 by t. So I will write on x-axis ln p set, on y-axis sorry, on x-axis it is log of p, and on my y-axis it is 1 divided by t. Okay, and what is predicted? Okay, so it is nothing but thing. Okay, on x-axis it is 1 by t in units of 1 by Kelvin is ln p set. Okay, so let's try to see. Okay, where did I make the mistake? Okay, here 1 by t, so it is 1 dot because it's a matrix. Okay, so see here we will have coefficients. So see it is well fitting. Okay, okay. The only issue is we have not kept everything in the order. See if I can do it. Wait, let me do it. So it will actually be better. 141. So corresponding to 140.2, what is the value? 207. 207. Then 141.1. Then this term 145.1. So what is corresponding to 145.1? That is 246. 6. Sorry. That is 246. Okay, then till these 3 points, 171.4 and 176.6. Sorry, let's do it step by step. So this 171.4, 171.4, what is the data? 564. Okay, then 173.5 is 601. 176.6 is 653. 181 is 740. Okay, this we can skip actually. Okay, so let's try to plot this. It will look a good plot. So see, this is looking like a good plot. So what are the coefficients that we are getting? 1, 2, 3, 13.3. So what is the value of coefficient of phenol here? C14 and we are getting 13. We will not get exact value because this data is really limited. Then second coefficient is 2788 and here it is 3507. And my last coefficient is 139. And here it is 175. Okay, so this is how we can plot. So I will just save it. Okay, so let's try to solve one more problem. Here we are told we are given value of time and we are given value of concentration. This is problem from your 11th spill. So we are supposed to find a value of rate constant n. So let's, I will just copy this thing. Okay. So my time t zero, 20, 40, 60, 0, 20, 40, 60, 120, 180, 200, 120, 180, 300. This is my time. And my concentration is 10, 8, 6. My concentration is 10, 8, 6, 5, 3, 2, 1. 6, 5, 3, 2, 1. Okay, this is my concentration. So what is my model? Model is Ca raised to 1 minus n. Okay, this will be difficult using this thing. Okay, what we can do? Ca raised to 1 minus n. So I can write my Ca0 is equal to C of 1. Correct? That will be my initial concentration. So what is the equation? Ca raised to 1 minus n. So like this. Raised to 1 minus coefficient of 1. I will have to put one dot here. Minus same thing. Okay, this whole minus yeah, similar term, but it is Ca0 minus n. Okay, and this whole term is divided by n minus 1. Okay, my initial guess is, let's say it's just 0. And I want to fit model coefficient 0 with my x-axis concentration. And it is k into t. So what is the value of k given to us? Okay, k is not given to us, so I will have to open the 11th spill. Chemical reaction engineering. What is that problem? Chapter 3, 3.1. Chapter 3. Yeah, I guess we are also supposed to fit K. Write it as coefficient n minus 1 into coefficient of 2. Okay. And here on y-axis, we'll just fix time. Okay. So let's see what we are getting. Yeah, this is correct. And I want to plot it. So I will just copy this equation. Okay. Let's try to plot on x-axis. It is time. On y-axis, it is C. So here also on y-axis, it is time. On x-axis, it is C. What is the unit? Time is in second and concentration is in mole per liter. Time is in second and C is in mole per liter. Okay, so let's see if we are getting exact answer or not. Yeah, this thing, CA0 thing. So what is the value of CA0 is 10. So let's just write 10 here. Okay, there is, okay, yeah, there are two coefficients. Okay, that's why. We have two coefficients. One is 0. Let's keep 0, 0 both. Okay, it is not solving it. So let's take 2 comma 1. So see, we are getting n is equal to 1.4347. Are we getting that? Let's check from here. So what is the value of n we are getting? 1.43 and k is coming out to be 0.0048. So this is matching. Okay, so I will just save it as order of reaction. Reaction underscore order. Okay. Okay, so this is about problem 2. Okay, we have one more problem. We'll solve this because this is the last class. So how eccentric factor is defined? Eccentric factor is omega is equal to -1 minus log 10 PR set at TR is equal to 0.7. So my equation will be log base 10 PR set at TR is equal to 0.7 is equal to, if you see this, log PR set versus 1 by TR. So one will be slope and one will be intercept. Correct? So if I get this value, if I can fit this log base 10 PR set at TR is equal to, if I can first feed this, so I can find value of log base 10 PR set at TR is equal to 0.7 and I can plot omega. So see, I have value of TC and PC. So what I can do, so let's do it. I just want to see what is the value of omega, eccentric factor. So we have TC is equal to 562.2 Kelvin. 562.2. Why do we need TC? Because we have TR and PR. Then PC is equal to 48.98 in bar. So how can I convert it into bar to what is the unit that we want? Bar to kilopascal. So let me check from bar to kilopascal. So that is into 100. Okay, into 100. So I will write down here as kilopascal, and here it is in the unit of Kelvin. Okay, so I have P is equal to, okay, I have value of A is equal to 13.7819, 13.7819. B is equal to 2726.81, 2726.81, and C is equal to 217.572. Okay. So let's say I'm keeping my temperature is equal to what is the unit of temperature is in Celsius. So let's say I'm doing it from 100 to 500 in range of 10. Okay, one very important thing you need to take care of. Okay, let's first find out the pressure. So pressure is equal to exponent of, okay, first write down A minus B divided by T plus C. Okay, so this is my pressure and this whole term is in exponent. Okay, so what is the catch here? So I will have to find out PR and TR. Okay, so what is PR? PR is equal to reduced pressure P divided by PC. Correct? And TR will be equal to T divided by TC. But what is the catch here? Here my temperature should be in Kelvin. So what I can do? I can do T plus 273.15. Here it should be in Kelvin. Okay, so I have found PR and TR. Now what do I need to do? I need to fit my first order polynomial to find this log base 10 PR set. Okay, so I can write down log. Okay, how can I do it? Let's first this copy this format. So I will find out coefficient. What is the coefficient on x-axis? It is 1 by TR. Correct? It is 1 divided by TR. And on x-axis, it is, okay, log 10. So I need to mention log 10 of PR, and I want to fit first order polynomial. No, I guess it is x comma y, not y comma x. Yeah, this is correct, x comma y. Okay. So what will I get? I will get the value of slope and intercept. Okay, there is something. Yeah, okay, here it is comma. Okay, so from here I got the coefficients. So what do I need to do now? I need to find that value at 0.7. Okay, so I should put my TR is equal to 0.7. So what can I do? I can find log 10. Okay, what should I write? T underscore 0.7 is equal to M into X. So what is my slope? Slope is my first term is slope. So coefficient of 1 into 1 divided by 0.7 plus coefficient of 2. So this will give me the value of this. And what is my eccentric factor? Omega is equal to, or let's write eccentric factor. I can't write like this, so I need to put one underscore is equal to -1 minus P underscore 0.7. I am just writing log P, so it's not an confusion. log p. So this will give me the value of eccentric factor. So let's see what we are getting. Okay, there is some issue. Okay, I can't write it like this. Okay, I'm just writing 7, not 0.7. It's not taking it. So my eccentric factor is coming out to be 0.18964. That we solve this for benzene, right? So let's try to look what is the eccentric factor for benzene. So if we chemical engineering, it won't be exact value at any cost, but we will get something near because we have very less data. From here, we will somewhere, yeah, see benzene it is 0.210. Okay, so we did not get exact answer. But if we increase our these ranges, or if I do it more often, let's say from 10 or 30, so this may improve our data. I'm not saying it will improve, but the main catch is what is the temperature limitation. So let's see, I have taken this value from here only. So for benzene, what is the temperature limit? It is from 6 to 104 Celsius only. So I should take from 6 to 104 and I should calculate it at every point. So see, it is giving 0.1818 only. So this is not something we are exactly getting it. 6 to 104, yeah, temperature range Celsius. So this is the temperature range in which only. So from this, I am getting my eccentric factor as 0.1818. So what did we do in this problem? We generated vapor pressure data, then we generated first vapor pressure data using this equation. Then we used this log 10 PR set and we plotted it versus 1 by TR and we found this coefficient. Then we put TR is equal to 0.7 and we calculate the value of omega. Okay, so I hope this is clear to everyone. If we want to plot x on x-axis, it is 1 by TR, right? 1 by TR. 1 divided by TR. And on y-axis, it is log 10 PR, that is on y-axis. Then I can keep it like this. And I can keep hold on. I can plot 1 dot TR so I can use this term model. Okay, like this we can do. So I can write this same term model and we can do dash. Then on X label, we can keep 1 by TR. On Y label, I can keep log 10 PR and my this thing is same. Okay, so let's see what we are getting. Are we getting exactly straight line or not? That is the catch. Where dimensions should agree. No, but I'm just giving, okay, yeah, it should be like this. I'm sorry. Yeah, it is matching well, but still it is not giving us the exact answer. Okay, so this is how we can calculate eccentric factor. So this is all from my side for this whole course. So in today's class, we learned how we can use optimization tools. Then further, we learned how we can use data fitting using polyfit and lsqcurvefit for nonlinear fitting. So that's all for this course from my side. Thank you. And on Thursday, I will be conducting one revision session. So those who are willing to join, please join. We will see we will see what we have learned in this course throughout 2 hours. Okay. So thank you everyone.